Student notes, parent functions. This is beginning of Unit 5. To begin with, what I'd like you to do, please, is I'd like you to start by filling in as much of this information that you know, rather than just copying it all down, and then go back and check your work based on what is written here. So pause the video now, enjoy the beautiful jellyfish, and then after you're finished with that, you can fill in your information. Notice in the tables, your domain and range for each is given in both set and interval notation, whichever one you're more comfortable with, but please understand the other as well. Remember, when graphing, you must adhere to those critical values and do your best to graph as closely to them as possible. General form is also known as vertex form, and it follows that same pattern that we've dealt with in the past. Some forms still use H and K. Other forms of the equation substitute H and K for C and D. So I've gone ahead and written both so that you're familiar with both based on what you see in the work in the days ahead. Please notice, as we've talked about before, that if the coefficient of x is not 1, you must first factor it out so that you get the proper stretch and compress as well as the proper shift, either left or right. So please keep that in mind as you're working on some of these problems. You'll see that as we move forward. Next, what we're going to work with are some transformations of the square root and cube root functions. So we'll go ahead and work through these problems. This is very similar to the ones we've done in the past. What we're going to do here is we're going to start with the parent function y equals the square root of x, and then in the second one we will use our transformations to write our new ordered pairs. So remember your critical values, they are going to be the ones that you always start from. Now we'll apply the transformations to those same critical values, and that will help us identify the transformations. Now recall, on past tests we've worked only from table forms, so that's one reason why we're starting with table forms, so that you stay familiar with the way that you read a table to understand the transformations that occur. So there's my parent function. I'll go ahead and use a different color for my transformed function. You'll notice that the first point demonstrates the shift both right and down, which is consistent with the numbers that have been given. From there, all you need to do is count your critical values: over 1, up 1, over 4, up 2, so on and so forth. And the reason I know those critical values won't change is because there's no stretch or compression in this one. Transformations are right, 4, down 2. Domain is going to be from 4 through infinity. Range is going to be -2 through infinity. By this point, you should be recognizing that the domain and range also demonstrate that same shift, both right and down. Alright, we'll start with our parent function y equals the cubic root of x, and that's going to be your critical values of -8, -2, -8 because that's a perfect cube, -1, -1, again a perfect cube, 1, 1, and 8, 2. Now we can apply those transformations: -6, -4, 1, -2, 2, 0, 3, 2, and 10, 4. Start with our parent, 1, 1, -1, -1, 8, 2, and -8, -2. Now we'll apply those transformations. So we have the shift to the right, and we have a stretch of 2. So we have a right 2, vertical stretch, also factor of 2. Your domain and range for the cubic root function is all real numbers. Alright, number 5, we have several different graphs, or tables I mean. We're going to apply 2 different transformations so that we can see them separately. Back to the square root, y equals the square root of x. So we've got our critical values of 0, 0, 1, 1, 4, 2, and 9, 3. Alright, we'll begin first. We'll begin first with both our movement to the right, movement to the left, and our compression, and then our third table will follow up with our movement down. So we're going to start with -2, 0, and then -1, -1/3, 2, -2/3, 7, -1, and now we'll apply that shift: -2, -4, -1, -4 1/3, 2, -4 2/3, and 7, -5. Again, starting with critical values, and from there we will apply our transformations. You can see here we've got a pretty big compression vertically, where the line hardly curves at all. Alright, transformations reflect the x-axis. Vertical compression of 1/3, and left, 2, and down 4. -2 through infinity is my domain, and because of the reflection, my values swap. At this point, please make sure that you are writing your smallest value first. That does include -infinity. Alright, finally, we're going to write equations from graphs that have been given. The first thing we're going to identify are any transformations of any kind, so we've got to do some investigating. Remembering our critical values will help us determine if there's a stretch or a compression, and we'll obviously see changes if there's reflections and transformations, left, right, or up and down. So I obviously see the transformation to the left. I will be also identifying critical values to determine if there was any sort of stretch or compression. And as you can see, those critical values line up perfectly. Over 1 up 1, over 4 up 2, over 9 up 3. So there's no stretch or compression. So that means this time the only change was the leftward shift. Because it's to the left, it will be inside. So that's going to be x plus 2 underneath the radical symbol. Domain, -2 through infinity. And our range is 0 through infinity. Number 7, the equation given is a cubic root. Now we've got to identify all of the things that are going on. Notice we have a reflection because normally it has a positive correlation where the graph is moving upward as opposed to down. We have a shift vertically down 2 units. And we must identify those critical values to determine if there's a shift of any kind in the form of a stretch or compression. There isn't, so we will simply write our equation, the reflection represented by the negative. Remember your index value and our transformation down means that our 2 will be clearly on the outside of the radical symbol. Domain, all real numbers, -infinity through infinity. Range, also all real numbers, -infinity through infinity. Alright, the last thing we'll discuss, well, second to last thing we'll discuss is stating transformations, and the critical learning point here is that you're identifying the coefficient of the x. Notice the coefficient of x in both of these cases is not 1. So in order to get the appropriate transformations, you must first factor that out from the value that is given. If you do not see parentheses, assume that the values have been distributed. So you can't assume that this is 2 times parentheses x plus 4. You must assume instead that it is 2x plus 4 with a common factor of 2. Now that we've factored that out, we can see that we have a horizontal compression with a factor of 2, and we have a left shift of 2. Notice how that changes from the original. We would still get that horizontal compression of 2, but instead we would have said that it was left 4 instead of left 2. So it affects your translations. Question number 9, same way. Y equals the square root of -5 times x minus 3. If we factor out that negative, it changes the symbol on the original 15. Now this transformation would change everything from the original to the other. You would get your reflection, that's true. You would also get your compression, that's also true, but now you notice it's going in the opposite direction than what you would actually have as a correct answer. So now what we're going to have here is a horizontal compression of 5, a reflection across the x, sorry, not the x, the y-axis. That means that it's going to move from this posture to that posture, that orientation, and we are going to have a right movement of 3 units. In your notes, I took off question number 10 due to time, as well as taking off question number 12. The last thing we're going to do is describe transformations from one to another when neither of them is the parent. So now what you're going to have to do is identify the shift from one to the other. A very simple way to do this for visual learners would be to simply graph it. So graph both of them separately, look at each differently, and see how they compare to one another. Now looking at them in a graphing format, you'll notice that the number 2 increases to the number 4, which means I have a further stretch of this from the parent function y equals the square root of x. So that means I have a vertical stretch of 2, factor of 2. Now to go from -3 to +2 means that I've gone from right 3 to left 2, which means the total transformation, the total translation is going to be left 5 units.